Today we're just going to calculate the change in the internal energy of the system. So in review, the change in the internal energy is going to be equals to Q plus W, where the change in the internal energy. So this is the change in the internal energy. So if you still do not know, the internal energy is basically the sum of kinetic energy and the potential energy of the system. I'm just going to quickly write this out, so you will take some notes. This is a little bit important. Okay, here. So this is the change in the internal energy. So this Q is, as we know, this is going to be the heat energy. Oh, I double my R. Okay. So W is going to be the work. So this is the important notes on the right sides. So this is by the system. If it's done by the system, it's going to be have a negative work. But if it is done on the system, that's going to be positive work. So by meaning work is going to be negative. So if it's on the system, meaning it's outside, therefore it is going to be positive. It's basically done by the surroundings, not the system. So now if the heat energy is if the system absorbs heat energy, therefore the Q is going to be positive. If the system just release some heat energy, therefore the surroundings will have the positive sign, but the system is going to have a negative sign. Now let's work into this problem. Calculate the change in the internal energy of the system if 600 joules of heat energy is absorbed by the system and if 800 joules of work is done on the system. So basically it is on, meaning we have work is going to be positive because it is done on the system. And the energy, heat energy, is basically absorbed, meaning we have a positive sign. So all of our constant here are positive, therefore we just have a positive change in the internal energy. So that's going to be around 1400 joules. Okay, now let's work into second example. The system releases 1400 joules of heat energy and 600 joules of work is done by the system. Calculate the change in the internal energy by the system. So we're just going to put some equation here. So that Q is basically release and work is done by the system. So the change in the internal energy is going to be negative 1400 joules and negative 600 joules because it is done by the system. So this is opposite of earlier. So our answer here is going to be negative 2000 joules. So this is the answer. What is the change in the internal energy of the system if the surroundings gain 500 joules of heat energy and if 910 joules of work is performed by the surroundings? So the change in the internal energy is going to be negative 500 joules because the surroundings, our system just release heat energy. So it's going to be negative 500 joules. And the work done is by the surroundings, which means it's going to be negative on the surrounding sides, but it's positive on our system. So that's why we get that answer. What is the change in the internal energy of system if the surroundings releases 600 joules of heat energy and if the system does 1100 joules of work on the surroundings? Now we're going to illustrate this. So this is our system and the surrounding just releases 600 joules of energy, which means that our system is going to absorb 600 joules. So we have a positive Q. And then the work is done on the surroundings, meaning we have a positive work here. And then we will get negative work on our system. So The science that we're going to follow is the system because we're in thermochemistry. So let's plug it in all in. So the change in the internal energy is going to be Q plus W. So the change in the internal energy is going to be 600 joules minus 1100 joules of work. So meaning our internal energy is going to be negative 500 joules. So this is the answer for this problem, and I hope you learned something today, and goodbye.